Hi, boys and girls. I am excited to tell you that this is the very last lesson on volume for this year anyway. And we're going to bring something into our volume that we have not before, and that's called rate. Now, we've discussed rate before, and we've done problems on rate. I think we did the rate of speed is what we have been used to doing. And you've probably done some of that in your science classes as well. If we are given the rate of flow of water, such as the number of liters per minute, and we are given the total volume of a tank, we can use rate concepts to find the time it takes for the volume to flow out of or into a tank. So rate. Rate involves two quantities that correspond to each other, usually expressed one quantity per unit of another. For example, I drive usually 65 miles per hour. So that's a rate of speed. The flow of water is also a rate. We can say that water fills a tank at a rate of 50 liters per minute. So in 1 minute, that's 50 liters. 2 minutes, that's 100 liters. So that's rate. So let's say a tank is filled with water from a faucet. So we have our faucet turned on, and water is flowing out of the faucet, and 200 liters flow into the tank in 5 minutes. So how many liters will be in there in 8 minutes? So the first thing you have to do, real simple. So 200 liters in 5 minutes, so 5 minutes basically equals 200 liters. I need to find my 1 minute. So I just divide 5 into 200, which is 40. So I'm thinking in 1 minute, 40 liters. So 40 times 8 will give me 320 liters in a minute, right? I mean, in 8 minutes. And that's basically what we're talking about. But we're kind of talking about it on a little more advanced level. So I just wanted you to kind of give you that it's going to be okay pep talk. So here we have a tank. Here's my tank. Our tank is 80 by 50 by 60. And here's our little faucet. And our tank is filled to the brim with water. So you can't see it, but it's filled up. That tank is filled up with water. So a rectangular tank measures 80 by 50 by 60. It's filled with water to its brim. If the water is drained out at a rate, there we go, of 12 liters per minute. 12 liters per minute. Okay. Then how long will it take to empty the tank? And they give you this little hint, 1 liter equals 1,000 cubic centimeters. Okay, so the first thing we need to do is find our volume of water, and you know how to do that. The water's filled to the brim, so just take the volume of the whole tank and you'll have the volume of the water. So the first thing you want to do is volume of water, H2O. It's the scientific symbol for water. So we're going to do length times width times height, 80 times 50 times 60. There we go. Can you see that? Okay. And then if you notice, our measurements are in cubic centimeters, but they want our answer in, yay, liters. So we're going to have to change our cubic centimeters to liters. And that's okay, because we know how to do that. So we are going to divide all of that by 1,000 cubic centimeters to get our liters. Okay, so we can do some math. There are two ways. Well, there's a little shortcut you could take, but let's say we know that 8 times 5 is 40, right? We know that 6 times 4 is 24, right? Okay. Did I just confuse you? Let me try that again. 8 times 5 is 40, and there are 2 zeros. Okay. When I multiply that times 60, 4 times 6 is 24 with 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay? I'm not trying to. Anyway, that's going to be divided by 1,000. I'm going to I can take 3 zeros off of there. 1 into 240 is 240. All right, so we have 240 liters. All right, so now if we have 240 liters, we want to know the rate, okay, if the water is drained out at a rate of 12 liters per minute. Okay, so we're going to divide that by 12 to find out, excuse me, I'm going to sneeze, how many minutes that will take. Excuse me, sorry. 12, I'm going to divide that by 12. And 12 into 24 goes 2. I'm going to drag that 0. So it'll take 20 minutes. It'll take 20 minutes. What I was going to show you is that this has 3 zeros and there were 3 zeros. So if I took out those 3 zeros, I'd have 8 times 5 times 6. So I'd have 30 times 8, which is 240, which I could have gone from here to here. It's neither here nor there. All right, so time taken. Time taken. Well, 20 minutes. So for this whole tank to be drained by this faucet going at 12 liters per minute, it would take 20 minutes for all that water to drain. Okay? Hold on a second and I'll show you the next one we're going to do. That wasn't too bad, was it? Welcome back. Okay, so remember yesterday when I had the cup and I put the Santa figurine and Santa displaced the water and made the height of the water go up? Okay. What we're going to continue to talk about that. Here's a similar but different problem, because now in our tank we have 4 cubes, and cubes by definition have the same length, width, and height. So we have 4 metal cubes of edge 5, which means 5 times 5 times 5, right? So 5 times 5 is 25, and 25 times 5 is 125. So each of these is 125 cubic centimeters. All right. So that the first thing we have to do is find out how much displacement has happened because of these cubes. So let me read the problem to you. 4 metal cubes of edge 5 centimeters are placed in an empty tank measuring 20 by 20 by 11 centimeters. Now the tank is then filled with water flowing from a tap at a rate of 6 liters per minute. How long will it take to fill up the tank? Now, without the cubes, we could just find out pretty quickly. We could do volume and then all we'd have to do is divide the volume by the rate, and boom, we'd have that. But because we have the cubes in the tank, we have to figure out the displacement of the cubes. So first we have to find the volume of those cubes. So volume, hope you can see this down here, volume of 4 metal cubes. Okay, you see that? The volume of 4 metal cubes, of course, is going to be 125 times 4, because there are 4 of them, all right? I'm going to multiply. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 1 is 4, plus 1 is 5. So 500 cubic centimeters. So I'm just going to say, boom, it's 500 cubic centimeters worth of volume there. All right, now let's find the volume of the whole tank so that we know that volume of tank. All right, so that's going to be length times width times height. So 20 times 20 times 11. So we can say this is 2 times 2 is 4, with 2 zeros is 400. 4 times 11 is 44, with 2 zeros. So 4,400, and that's centimeters cubed. Okay. So without the cubes, we would be dealing with 4,400 cubic centimeters, and we'd be dividing that. But because we have the cubes, we've got to take those into account. So we basically have to subtract the 500 volume of cube away from our tank volume. So we would say 4,400 minus 500, and we would get 3,900 cubic centimeters. Now, the problem with that is that it's not in liters, because they want to know how long will it take to fill up the tank, and they want to know in liters. So now we're going to change our cubic centimeters to liters, and we know that 1 liter equals 1,000 cubic centimeters. So we're going to move our decimal back 3 places, 1, 2, 3. So 3,900 cubic centimeters is the same as 3.9 liters. All right, we're not done yet. Honestly, we're close. So now all we have to do is divide 6 liters, because we can do 6 liters per minute, right? We can do 6 liters every minute. So 6 liters into 3.9 liters will give us the time taken. So our time taken is 3.9 divided by 6. Let's do that up here because I just don't have any room now. I know that 6 will go into 39 6 times. I'm just moving my decimal up because that's what I do when I am dividing with decimals. 6 times 6 is 36. I'm going to subtract, bring down my 3. I'm going to bring down a imaginary 0, and 6 into 30 will give me 5, and that's going to give me no remainder. So it's going to take me 0.65 minutes. 0.65 minutes. That is how long it's going to take to fill up that tank, going 6 liters per minute. It'll take 0.65 minutes. So there you go. Be happy. This is the last Lesson on volume. I'm not going any deeper than this. Yes, it's challenging. Call me if you have a problem, but I believe in you. You can do this.